Let's design a bank. What is a bank? Well, you probably have some familiarity with it. Usually people store their money in a bank, and there's a lot of things you can do. The basic things are depositing money and withdrawing money back from the bank. And there's a lot of other financial products that banks can offer. There can be interest, there can be loans, there can be a bunch of consumer products, investment products. So it definitely matters what functionality we're going to implement because banks are pretty complicated. So what types of questions could we ask our interviewer? Well, what types of services is the bank going to be offering? What types of accounts can customers open up? Do they even need an account in the first place? If so, what type? Will the bank have like physical locations, or is it just going to be like an online bank? How is that going to affect our design? If it is physical, are there going to be actual people working in the bank, aka bank tellers, that are going to be handling the transactions? And if it is physical, are we concerned with like the security of the bank, and how is that going to work? The bank is obviously going to have like cash stored at the bank, and is it going to be just a single branch, or is it going to be like one central bank, like headquarters, and then a bunch of smaller branches distributed around the world that we're going to be keeping track of? Now let's quickly go through the answers to these questions. In terms of services, let's keep it simple and say we are just going to handle deposits and withdrawals. And yes, customers do have to have an account to make these transactions. If they don't have an account, they have to open an account. For locations, let's only handle the physical case because that will be a bit more complicated than if we were just an online bank, because that would be pretty simple. We would just have like a central interface to go through. But with physical banks, we'll have multiple branches. Let's say that every transaction does have to go through a teller. If we have a bunch of physical locations for the same bank, let's say we do have a single headquarters for that bank. In terms of security, we're going to do something a bit interesting and unusual. Let's say that every day the bank will take some percentage of money that it has and then send it to the headquarters. We don't have to worry too much about like the transportation, but let's assume there's like an armored vehicle or something that will do that for us. But we don't have to worry about it. We do have to keep track of the percentage that is going to be transferred to the headquarters. And we can also add new branches in different locations. Where would those branches get money from? Well, initially they would get money from the headquarters so they can have at least some amount of money. And if a customer is going to deposit or withdraw from a branch in one location, they should be able to get the same amount of money from another location, just like you can in real life. Like, it doesn't matter which branch of the bank you go to, as long as it's the same bank. Let's say it's Chase Bank or something. It's a pretty big American bank. It doesn't matter which branch you end up going to. You can get your money from either one because it's the same bank ultimately. So this is quite a lot of stuff to keep track of, but the solution is not as complicated as you would expect. Let's start with the high level. Of course, we are going to have customers, and customers are the ones that are going to be performing transactions. What types of transactions are we going to have? Well, we know we're going to be able to deposit, withdraw, and not only that, but actually open an account. And I think it makes sense to make that a transaction as well. Of course, if we were going to extend our design, there's a bunch of other transactions you can do more than just these at real banks, of course. But I didn't mention this earlier, but let's say we also want to keep track of all the transactions that a customer performed. We know that all of these transactions, they have to go through a teller, not just a customer, but they have to be done at a physical location through a teller. And let's say we want to record who was the teller that did each transaction, maybe for fraud reasons. If a teller maybe stole money from you, we would want to be able to know that via the transaction details. Now, since we know that every customer is going to need to have an account in the first place, that's going to be like the transaction that they do, and we can tie the account to that transaction, which is opening an account. And then after that, any withdrawal and deposit will also be tied to this account. We actually don't even need a customer. What would a customer even encapsulate? Just the name of somebody? Well, we could have that all tied in to their account. We can have their account have all their personal information like their name, a unique ID to identify the account. That probably will be generated by the bank. That probably shouldn't be provided by the user, though there might be some use cases where we could have some unique IDs, such as like a social security number in the United States. That would probably work. But let's say that we will still have our own internal unique ID that we generate for every account. The account will also have information about like what the balance is, because that's really the only thing we're keeping track of, the amount of money that's in an account. We're not worried about like interest rates or anything like that. But to now actually move on to the actual bank, we're going to have like a central bank or the headquarters or something to keep track of like the main entity that is the entire bank. But we know we're going to have individual bank branches. This is like a physical location that is a part of the bank, but there could be multiple bank branches. So I'll illustrate that with like some overlapping rectangles. The individual bank will have, let's say, a list of tellers that work there. So we can have an array for a bunch of tellers. Every time a customer wants to do a transaction, we will just pick a random teller to serve them, sort of like having a queue. And we could go more into the details of like the implementation for that, but let's try to keep it simple, though I encourage you to try out your own ideas if you have any. But each bank branch is also going to have like a physical amount of money that it has, like the physical cash that belongs to that individual branch. The entire bank is also going to have some cash reserves that we know some percentage of the cash from the bank is going to go to the headquarters, and then sometimes some cash from the headquarters can go to the bank branch. Now, to keep track of the accounts, like we know we're going to have a bunch of accounts. If you open up an account at a single branch, that account obviously exists at every other branch. So we need like a centralized store to keep track of all that information, as well as, let's not forget, we need to keep track of the transactions. Where are we going to keep track of those? Well, those also should not necessarily be stored in a bank branch. We could store it in the entire bank entity, but I think it makes sense to have a separate class for that because the entire bank shouldn't be responsible for those like low level details. So let's create another class, which we can call like the bank system or banking system. That's like maybe their IT operations, their like mainframe or whatever the bank is running on these days. And that will keep track of all the accounts that exist, as well as the transactions for each of those accounts. So we'll never lose any of that data. I think this is pretty much it for a high level. Let's dig in to the code now. So let's start with our transaction, because that's like the smallest unit that we're working with, and we're going to make it an abstract class. In terms of the constructor, we know at the bare minimum it's going to be tied to some customer, and in our case we know it's always going to be a physical transaction, so a teller is always going to be involved. But this is extensible enough that if we were working with a different design, maybe we didn't have tellers at all, we could have just removed this and then extended the transaction class, and some transactions involve a teller and some don't. This is a pretty extensible way to do it. Now, the abstract method in our case is just going to be getting the transaction description. We know that could be different based on the transaction itself. We know deposits and withdrawals are going to have money, but opening an account is not going to, which moves us to the 3 individual transactions that we're going to be implementing. One is going to be a deposit, pretty simple. It has a customer, a teller, and an amount. We save the amount. And in terms of getting the transaction description, we're going to do this in a pretty simple way. But again, this is extensible enough that this could have more complex logic if we wanted to. The description is basically the teller with this ID deposited this amount into this particular account. And withdrawals are going to work pretty similarly, except it's going to be this teller withdrew this amount from that account, etc. And opening an account is going to be slightly different. This teller opened this account with this ID. A bank teller is going to be pretty simple in our case. They're just going to have an ID, though we could fill out additional functionality if we wanted to. Now we get into the more interesting part, which is an actual bank branch. Let's just say that a bank branch is going to be uniquely identified with the address. A branch will also have some cash on hand and will also pass in the banking system so that this has a reference to the banking system, so that every time we do a transaction, that transaction is recorded in the banking system. Also, we will have a list of tellers. In our case, we won't pass those in via constructor, though we could if we wanted to. But we know the tellers could be dynamic. Maybe sometimes some tellers quit, or sometimes they have different shifts. So it's acceptable to have like a method that adds tellers, and probably we could have added another one that removes tellers as well. But for simplicity, let's move on from that. Getting an available teller is basically needed for all of the transactions that we're going to implement. If a customer wants to open an account, they pass in their name and we create an account with that name. But before we do that, we know that a teller has to be involved. So we have to get an available teller. If our teller array is empty, then we don't have any tellers available. So then we can maybe just throw an error. Depositing is pretty similar, except instead of opening an account, we are just depositing money, but that still has to go through our bank system. The bank system will update the amount of money that that account has in a centralized place. Same thing with withdrawing, but we have another error handling case, which is what if the branch itself doesn't have enough cash that the customer wants to withdraw. Even if they have that amount in their account, maybe the branch just doesn't have enough. Maybe they have to go to a different branch. Normally, you wouldn't want this to happen in real life, but it's just an example of error handling that we could add. There's a couple other methods for collecting cash from the bank, and we pass in a ratio like I talked about. Maybe it's 10%, maybe the headquarters wants to collect 10% of the money from the bank, then we would decrement it. We would calculate that amount and then decrement it from the cash on hand. If we wanted to provide cash from the headquarters, we would just pass in the amount and then add that to the cash on hand. Now, a bank account, which is pretty important in this case, will have a customer ID. Now, this customer ID will probably be assigned by our banking system. We'll have a name for the customer, but that's not going to necessarily uniquely identify them. We'll also have an initial balance. It could be 0. Maybe that would be a good default value to have in this case. And other than that, we'll be able to get the balance, add money to the balance, or withdraw money from the balance. But all of these operations are going to go through our banking system class because those bank accounts can't exist without the banking system. This is our centralized store. We could have some initial accounts and some initial transactions, but most likely those are just going to be empty. We'll be able to get an individual account because our accounts is going to be a hash map where the key of the hash map is going to be the customer ID and the value is going to be an account object for that customer. Our transactions is going to be an array of the transactions that we talked about up above here, either deposit, opening an account, or withdrawing. And each of those is also implemented down here. When we open an account, we have a customer name. We're not given the ID, we're just given the customer name and the teller ID, but we generate a new customer ID. The way I'm doing it is the most simple way, just taking the length of the accounts that we have created so far. So we're pretty much just starting at 0, then saying the next customer ID is 1, then 2, then 3, just plus 1 every time. Then we create that bank account with an initial balance of 0 and then append that account to our list of accounts. I think I accidentally mentioned up above that our accounts array is going to be a hash map. That's not what I meant. It's actually an array where the key is the index, because it's not an actual hash map, because the simple way that we implemented it, we don't even need a hash map because we can just use an index as the key. But maybe a more extensible way to do this would have been to use a hash map. After we open the account, we also want to log that as a transaction. We do have a customer ID now, so we can use that to log the transaction and then append it to our list of transactions. We're going to do pretty much similar things with deposit and withdrawal. They're just wrappers around the bank account class, which will update the bank account here with account.deposit and account.withdraw. On top of that, we want to also log the transaction as well. And lastly, we are going to have our actual bank entity, which is going to be a wrapper around everything. It's going to be composed of a bunch of branches, which are going to be passed in a banking system. There's only going to be one single banking system for every single bank. It probably would be fine to also instantiate that banking system within the bank, I think, but I just passed it in because it doesn't make a huge difference in this case. It's also going to have some total cash amount. This cash belongs to the entire bank, but it doesn't include the amount of money that each individual branch has as well. We'll be able to add a branch with some amount of initial funds and some particular address, and we will append that to our list of branches. We'll be able to collect cash via some ratio from all of the banks. We'll probably do that every day or every some period or periodically some way. And then taking that cash will increment our total cash. So we're basically transferring cash from branches to the headquarters. And for readability and to be able to test this code, I created a print transactions, which will just go through every single transaction and call the get transaction description and then print that. Now, to actually test this out, it's actually going to be quite a bit of code, more than you might expect, because we have to instantiate a bunch of objects. We're going to create a banking system with no transactions initially and no accounts initially. We're going to create a bank, which is going to have have an empty list of branches initially. It's going to have that single banking system and initially $10,000. We're going to create a couple branches and add them to the bank. And to those branches, we're also going to add a few tellers. A teller has to have a universally unique ID, not just unique for the branch. So we're going to be creating that ID outside of the branch class. We're going to open a few accounts and we're going to deposit money into each of those accounts. And then we're going to withdraw some money from one of the accounts. And you can see that this would be a possible output. It's not always going to be consistent because the way, remember, we're choosing the tellers is randomly. So this output might be different when you run the code, but after we print it, it should look something similar to this. I definitely encourage you to run the code, test it out yourself, try writing your own variation, try thinking of ways that this design could have been different, try adding additional features to it to extend the design, and think about how you could make those trade-offs.